Okay, so our main goal here is to do the domain of a given function. All right. Now, notice how this one's linear, right? And so remember, any kind of polynomial or linear function, guys, the domain will always be all real numbers. Okay? All real numbers. So number 11 is all real numbers. Okay? Now, what I don't know for sure is how your teacher is going to have you write it. Can you just say all real numbers, or do you have to use like set notation? Like you could say I have the set X such that X is an element of all real numbers. That's like set builder notation. So this is something you just need to talk to your teacher. Can you just say all real numbers, or do you have to use some kind of set notation? Now, let me jump ahead. Notice that this one's a quadratic. So again, anything that's a polynomial, okay, is going to be all real numbers. Okay, all real numbers. But now, let's look at number 13 here. I just did 11, 12. Let's go to 13. So on 13, here is where it can be different. See that x squared plus 1 in the denominator. Can this equal 0? All right, that's the key thing. Can it equal 0? Because remember, we can never divide by 0, right? I can't just plug in here and have something divided by 0 down here. So the idea is that's where we get our asymptotes. We get those vertical kind of asymptotes and so on, okay? Well, in this case, because x squared is always positive and plus 1 means we're just making it more positive, right? It can never be 0. Hence, number 13, we also would say all real numbers. Now, if you didn't know this, what we're talking about here is x is the domain, by the way. Whenever they say domain, they want to know what can x be? What can x not be? So, on number 11 and 12, again, x can be anything. On 13, x could be any number you want. Okay? Let's look at 14. Now notice this one has x squared minus 1. Now what I'm hoping is you do realize that x squared minus 1 can equal 0. So one thing you ought to do is just set it equal to 0 and see if you can solve it. And so therefore if I add 1, notice that x squared is 1, and I can find x squared to be 1. Once I square root, x, you see, could be 1 or negative 1. And don't forget, whenever you do a square root, it's going to be a plus or minus answer now. So our answer is positive 1 or negative 1, plus or minus 1. So therefore, this one, you see, is all x's such that x is an element of all real, but x cannot equal 1 or negative 1. And so that would be the set building notation. Or you could simply say x cannot equal 1 or plus or minus 1. How about that? So that should be acceptable as well. But again, talk to your teacher whether or not you have to use set builder notation. Okay? So right here I would just say x not equal to plus or minus 1. That should work. All right, let's look at 15. Notice here, this one's going to be even more simpler. Can x plus 2 equal 0? Again, you're thinking you can never divide by 0, right? So you're trying to solve to see if you end up dividing by 0. Well, x equals negative 2 in that case. If I plug in negative 2, see, I'm going to end up dividing by 0. So therefore, this one is all x, right? Except, well, let's use set builder notation. So we'll do bracket x such that x is an element of all real. X does not equal negative 2. That would be our domain. X cannot equal negative 2. Why? Because we'll be dividing by 0. Okay, last one. Notice that this is a square root. Can I take the square root of a negative number? Like, for example, can I take the square root of negative 1? No, that's an I. That's a complex number, right? Can I take the square root of negative whatever? No, it's going to be some kind of I number, correct? So we're going to solve for 0. 2 minus x equals 0. Now, if I solve carefully, I'm going to minus 2. Negative x is minus 2. So then I know x equals positive 2, right? Because I can do a negative 1 on both sides. Okay? I could either times or divide by negative 1. X is 2. So in other words, do you agree if I plug in 2 here, I would get 2 minus 2, which is 0. Well, I can take the square root of 0, which is 0, but I can't take any number that becomes negative. So for 16, once you know that 2 gives me 0, x has to be greater than or equal to 2 is what we'd say. So x is any real number greater than or equal to 2. So in set builder notation, I would say bracket or brace x such that x, element of all real numbers where x is greater than or equal to 2. Now, sometimes your teacher will just let you just say x greater than or equal to 2. You don't have to say it's an element of real numbers. Again, that's the only thing I need you to talk to your teacher about. Okay, 17. This one hopefully should be very simple. Evaluate means plug it in. So f of negative 1, we're going to plug in negative 1. Now, if she lets you use a calculator, make sure you do the parentheses. Type it in exactly the way I have it written here. But I'm going to do it old school. I got 2 times 1, because negative 1 squared is 1. Minus 3 times negative 1 is plus 3, and that's still a plus 4. So I get 2 plus 3 plus 4. 5 plus 4 is 9. So f of negative 1 is 9. What about negative of f of x? You literally do the negative of f of x. So I get negative 2x squared. I'm distributing the minus here. Plus 3x. Minus with this minus makes plus 3x. And minus with the 4 makes minus 4. So that's negative f of x. What is f of 2x? Well, I'm literally going to take 2x and plug that in. See how I'm plugging 2x for the x? This is f of 2x. So 2x squared is 4x squared. We still need to times by 2. Minus 3 times 2x is minus 6x. And of course, we have a plus 4 at the end. So what is f of 2x? Is 8x squared, because 2 times 4 here is 8, minus the 6x. So 8x squared minus the 6x plus 4. All right, we got one more to go over here. 18. Again, what does f of negative x mean? I'm literally going to plug in negative x in there. See how I'm plugging in negative x? Well, the absolute value of a negative x is simply just x, right? So, absolute values are kind of tricky. So, basically, it's still going to be the absolute value of x minus 2, I believe. Although, technically, we are plugging in the negative of x. Yeah, so the answer, what's weird is this one stays the same function. All right, now what's f of x minus 1? We literally plug in x minus 1 in there. So f of x minus 1 is going to be the absolute value of x minus 1 minus 2. Again, see how I plugged in x minus 1 for x. What's f of 4x? I'm going to plug in 4x there. So it's going to be the absolute value of 4x minus 2. So I hope this video helps. Just email me or let me know if you're still having trouble with any of these practice problems. Okay, please discuss with your teacher whether or not you need to do what they call set builder notation, or whether or not you could just explain that it's all real or it's greater than 2 or whatever. Okay? All right, just let me know if you need help.